Hello everybody. First of all, thank you very much for the attention and the time you are dedicating to us. I am Elisa Mattavelli. I am the CEO of Emme Esse, and here with me there are two of my colleagues, Alessio Moscato, Product Specialist, and Andrea Ribolzi, R&D Leader of PHYSICO, our product. I'm very happy to be virtually here with you today, and I hope to be able to meet you in person as soon as possible. We have not much time, so let's go. We start with our symposia, and we are going to talk you about the real meaning of the implementation of a dose monitoring system, not about what is reported on books, brochures, or laws, but we will talk you about our experience in our daily work, the problem and also the solutions in our experience. We talk about how it's possible to successfully implement this kind of system, a dose monitoring system. Next slide. Okay, here our agenda. We propose a presentation in 3 parts. To me, the honor to make the introduction part about the company, the product, and again about how we work, talking about our philosophy and our approach to the product and our daily work. In the second part, with my colleague Alessio Moscato, we will go on the focus of the symposia, explaining problems and solutions through different case studies during the implementation of a dose tracking system. And at the end, just 2 slides to share our vision and project for the future. Okay, let's start. I introduce you, first of all, our company. Emme Esse is part of a group of companies. The holding, the mother, is MCG, founded 45 years ago, and we are an original made in Italy company. Our headquarters is here in Milan. Our group has grown a lot over the years in activities, in personnel, in skills, and in particular, Emme Esse works in the medical imaging field, in the diagnostic sector. During these years, we have followed and participated directly to the evolution of the radiology sector. And with the radiology, also Emme Esse has changed. We have evolved. We have made a real evolution. Now we are dealer and also producer of different hardware and software solutions. Emme Esse supply high technology systems, hardware, software, and services. Services for the creation and management of data and clinical imaging digital systems, and also services for the creation and the management and to give support and assistance to the digitization processes. You can come to our booth if you want in the exhibition area to discover all our proposition, also with 3 video about our experience and our products, or also on our website, surely. Next slide. Our product is PHYSICO. PHYSICO is a web platform for the computerized management of the entire medical physics and radioprotection workflow. A system for data collection, management, processing, and digital archiving, always accessible via web. With our system, the work of the physics is completely digitized, and so it becomes more efficient, with many benefits for its own activity, but also for the rest of the hospital. PHYSICO is a modular and customizable application. The platform is composed of 9 modules with different functionalities, tools, and application, and also with different possible architectures. Each module of the suite PHYSICO can be used standalone, but it can offer more value and more benefits integrating with other modules. Each client can create their own perfect combination of modules, application, tools, according to his own needs and preferences for a new, totally computerized and dematerialized way of working, a new, different, colorful way of working. We like to say that PHYSICO, it's a colorful word. Why? Let's see together. These are our colors. Our platform of 9 modules. Just a short overview of them. The first is the patient dose module, our dose tracking system, object surely of the rest of our presentation today. The second one, operator dose, for the computerized management of the personnel's dosimetry files for the work radioprotection. Environmental dose for the ambient radioprotection. And the next one, inventory for the management of all the equipment and their correlated accessories. And the next one is correlated with inventory is the module quality control for the computerized management of all the quality controls about modalities, accessories, phantoms, display, all the quality control made by the physics. Source module for the management of all the radioactive sources and wastes in the hospital, both instrumental but also for diagnostic and therapeutical sources. The last module of the family, radioprotection register for the creation, upload and organization of the all documents concerning radioprotection. And the last one, dashboard. Dashboard that is a business intelligence model, business intelligence system for the department, but also for the hospital management. It's aimed for the collection, the organization, and the analysis of all the data archived in Physico, surely from Physico, but also from the external information domains integrated with Physico. And it is based on indexes, tables, graphs, and dashboards. As already said, the focus of this symposia is not what, but how. How we approach our daily work with our customers is well represented by these few words. Innovations stem from men, with men, for men. This is our philosophy, and it is daily translated in concreteness, appropriateness, and usefulness. Our product reflects these principles with flexible, modular, and customizable tools. Our focus are really the user daily needs. And so, our dose monitoring system is developed considering, in fact, the workflows and the daily needs of medical physics. And we are able to support all the operators in the concrete and appropriate implementation of the dose monitoring system, from law to daily work, from theory to problem solving every day. In our system, there are a lot of tools and functionalities that help physics in this goal. And now my colleague Alessio Moscato will show you how. Thank you very much. I pass the presentation to my colleague. Please, Alessio.
I'm here. Thank you very much, Elisa. Good morning to everybody. I'm Alessio Moscato, Product Specialist of the Physico solution. During this speech, we will show some examples of real challenges in the implementation of an RDIM system and how Physico is able to deal with. We will focus our attention to three main topics: data collecting, data analysis, and final data sending. About data collecting from dicometer and or RDSR, we could experience some difficulties or have specific needs. Let's make some example. We could have information in non-standard or proprietary dicon tag. We could have multiple occurrences of dicon tags, for example, average glandular dose in mammography. We could have incorrect spelling or absence of imaged body part. That is an information necessary for those estimation. From this example, it is therefore evident that the implementation and management of an RDIM system could be very complex. The first example that we show is about a situation that can occur for mammography and tomosynthesis modality. The problem that we can meet in mammography could be that the RDSR is not always present, AGD and entrance dose could be given both for pulse and pre-pulse in the same DICOM tag. Laterality information could be stored in different tags depending on the acquisition modality, two-dimensional or digital breast tomosynthesis. Digital breast tomosynthesis acquisition could be sent as pseudo-CT images. And we also could have different acquisition, for example, RCC, LCC, and so on, that could be sent packed into a single series. So how Physico faces these issues? Through the mapping suite tool, which allows to customize tag selection for each device. It is possible to get a tag that is not collected by default, or to get multiple occurrences of a DICOM tag within a whole series or a single image. And there is a special option that allows to split acquisition packed in one series. The possibility to get multiple data within a single image allows to get the correct values for AGD and entrance dose, even if they are present both for pulse and pre-pulse. The possibility to collect different data for different subclasses allows to correctly estimate the cumulative dose for patient side, even if the laterality information is stored in different tags. The ability to split the DICOM series allows to correctly describe the entire study without the risk of losing data. The mapping suite features just described are useful to manage a bunch of other situations. For example, to manage exposure information in dual source CT, filtration information when more than one filter is present, like in interventional radiology, cumulative exposure parameters and data in dual arc interventional radiology, and so on. The second example is about an eventuality that can occur in CT modality, the misspelling of the body part. In this situation, the algorithm for dose estimation, either organ doses or effective dose, could be not correctly executed. For example, if a CT acquisition has orbit region in Italian language as target region. This is due to the fact that the manufacturer has implemented the scanner in an Italian hospital. The word orbite is not present in the list of available body parts used by the simulation software. For this reason, those algorithm uses its own defaults, that is the abdomen region. So how Physico faces this issue? Through another feature of the mapping suite tool. It is possible to transcode the body part in order to pass the desired value to the simulation software. Thanks to this possibility, the system is then configured to pass the I region to dose estimation tool when he read orbit. Dosimetry tool is now able to correctly identify the simulation region, and dose estimation is performed with maximum accuracy. There is also the possibility that the body part is completely absent. In those cases, Physico allows to transcode it from the name of the acquisition protocol. For example, we can get the head body part from the brain axial protocol name. The second main theme of this speech is about data analysis. So let's see some examples. We could need to manage two similar devices in different ways, for example, MGCT or MGBT. In some cases, the parameters of interest don't coincide with the raw data extracted from DICOM tag. For example, we need to standardize or modify the measurement unit. We need to estimate the right physical quantities. We need to estimate cumulative values for the study. So these examples show how the specialized users, physicists, need a way to interact with the estimation method. So let's see a practical example. We have two similar devices. Due to some reasons, first device stores digital breast tomosynthesis images in CT format, the second one in a BT format. In BT format, we had one image with the value of AGD of the entire acquisition and X AGD values for each projection, for example, 15 projection. In CT format, we have Y images, for example, 50 images, each one with the value of AGD of the entire acquisition. In order to correctly evaluate the AGD of the single acquisition and the cumulative value of the AGD, it is necessary for the professionist to customize computation formula for both cases. Physico allows to manage this situation with the dose editor tool. That is the tool that allows the physicist, the users, to customize the computation formula for each device that is mapped into the system. This slide is intended to show how it is possible to customize computation formulas according to different coming data. So we can see that series calculation of AGD could be performed as in one way, in BTKs in another way, and so on. So the system could offer many functions in order to evaluate and estimate values according to different situations. Of course, all of these configurations were made by default during the installation process by us. However, it will always be possible for end users to modify them if desired or necessary. The third main theme is about data sending and patient communication. Euratom Directive 5913 states that, information relating to patient exposure forms part of the record of the medical radiological procedure. So we have different regulations in European countries. Which data is to be communicated? How could be as accurate as possible? So the physical vision is a solution for every need. The first available solution is to define an exposure class level based on the name of the study. For example, we can assign a class 1, 2, 3, or 4 like Italian regulation based on study description. The second possibility is to define an exposure class level based on actual exposure or dosimetry values. So here we have some protocols of a single device, and for each one of them, we can define rules from which the dosimetric class is evaluated. And the third available method is to communicate actual values of those indexes. For example, DLP, CTDI for CT, DAP, KAP, SD, and so on for radiology, AGD for mammography, and so on. And every parameter that could be managed by the system. So the physical vision, in order to accomplish the Directive 5913, is a bunch of solutions that has the aim to go towards the needs of every country. So thank you very much to everybody, and I pass the speech again to Elisa. Thank you very much.
Okay, thank you, Alessio. I am back. And here we are. Alessio explained you how we actually can help our customer in the implementation of a dose monitoring system. Now we will talk you about the future, about how we are going to improve and innovate Physico in the next version. We are in continuous research of innovative and useful applications. Our R&D group are working to insert tools that will lead the system to greater contextualization within the workflow of a diagnostic imaging department. In our experience, it's clear that the real challenge is to guarantee an adequate level of functionality in different situations with heterogeneous technological levels. For MS, it's important to guarantee the continuous development of Physico, not only to stay up to date with the evolution of the law and the market, but also and primarily to ensure the highest possible levels of functionality. In this section, we will talk to you about two innovative applications that will characterize the next version of Physico. The first one, the inclusion of algorithms based on artificial intelligence. A critical factor found in several installations, as already mentioned also by Alessio, is the poor accuracy of the anatomical information communicated by the modalities. Often, in fact, due to a non-optimal implementation of the equipment, it is not possible to identify which part of the body was the real target of the specific acquisition. Using some algorithm developed by Emme Esse, PHYSICO will be able to recognize the body part acquired and compare this information with one communicated by the modality. This new feature will solve many problems found during the definition of dosimetric evaluation logics. Some example: greater accuracy of analysis, uniformity of data, and also, the last but not least, better rating for older modality. The second point, data portability. In the future, it will be even more important to ensure the possibility of exchanging data between different dose monitoring systems. This aspect is not only in many cases a low request, but also represent a great possibility to compare different experience of different organizations, different hospitals. On this point, the international community is working on the definition of communication standards that will allow data exchange in an easier and safer way than in the past. It is important that all software manufacturers update their system to new IHE standards and to the latest guidelines approved by scientific societies. We continuously work on it and to many other news. That's all. We arrived at the end. We make a short presentation because we know that there is a very wide scientific program during the days of this Congress. But we would like to say you thank you very much for your time. Thank you very much for your attention. We are at your disposal for questions, clarifications, and insights. Now, surely we have some time, a lot of minutes to answer to your questions if you want now, and you can send your questions by chat, but also at our booth. Tomorrow we will have a one-to-one conf call planned to our booth. So if you want, you can have the possibility to speak directly with us and to go in deep about our product and our solution. Thank you very much. We can see maybe if there is some question in the chat. Please, Alessio, if you can check. Okay, no question, right? I hope you have all the information about our product clear. And thank you very much another time for your attention, and see you at our booth in the next days. Thank you very much.